begin by defining what a composite function is. If f and g are two functions, we're going to define our composite function, f circle g, in the following way. We're going to say that f composed with g at any value x in its domain is equal to f evaluated at g of x. In this first example, we're going to try to find two composite functions, f composed with g and g composed with f. Let's begin by trying to evaluate f composed with g of x. Remember, by definition, this is f evaluated at g of x. Now I'm purposefully putting g of x in red here so you can see all I'm going to do is take the definition of f of x, and everywhere I see x inside my definition, I'm going to replace with g of x. So the rule for f of x is x squared plus 2 times x. But what we want to do is we want to evaluate g of x squared plus 2 times g of x. This means what we need is x plus 3 squared plus 2 times x plus 3. So now that we've made our substitution using the definition, let's go ahead and try to simplify this just a little bit. We can expand out here to get x squared plus 6x plus 9. And here we'll distribute to get 2x plus 6. And collecting like terms leads us to our final answer of x squared plus 8x plus 15. Next, let's try to figure out the function g composed with f. Now, according to our definition, this is going to be the function g evaluated at the function f. The function g is x plus 3. So g composed with f is going to be f of x plus 3. So let's make that substitution. F of x is equal to x squared plus 2x and now we can drop our brackets and collect like terms. So g composed with f is going to be equal to x squared plus 2x plus 3. Next, what we want to do is be able to determine the domain of a composite function f composed with g. Essentially, what we have to do is first determine the domain of the function g of x. Remember that the values that we get as output from this function then go into the function f of x. So if there are any values in the domain of g of x that make f of x undefined, we also have to exclude those values as well. So the easiest way for us, I think, to determine the domain of composition is to take a look at a couple examples together. In our first example, let's take the functions f of x equals square root of x plus 2 and g of x is equal to negative 2x minus 8. Let's go ahead and find f composed with g, and then after we found our new function, we will come back and try to discuss the domain of this composite function. So remember, by definition, f composed with g is we take the function f and we're going to substitute g of x anywhere we see x in our original function f. Now f is the square root of x plus 2. So there's only one x, it's right here. And for this value of x, instead of putting x here, we're going to put the entire function g of x. So negative 2x minus 8. Now we can drop the brackets and clean up just a little bit underneath that square root. So we're going to have the square root of negative 2x, and we have negative 8 plus 2 for negative 6. So here is our composite function f composed with g. Alright, now that we have our composite function, let's try to find the domain of our composite function. First thing we have to do is take a look at g of x. We need to figure out all the values of x that we are allowed to input into this function. Recall that our function g of x is negative 2x minus 8. This is a linear polynomial function, and these kinds of functions are defined everywhere. So we're going to say that the domain of g of x is any real number, or x is on the interval of negative infinity to positive infinity. Next, what we need to do is we need to try to determine the values in the domain of g of x that make our composite function undefined. Now let's go back to the last slide when we were first starting to compute our composed function f composed with g. Our first step would have been to take the function square root of x plus 2, and everywhere we see x, we're going to substitute in the function g of x. So if we want to find the values of g of x that make our composite function undefined, we need to figure out what values make this square root undefined. In other words, we need to solve g of x plus 2 is greater than or equal to 0. That's what we require for the composite function to be defined. Let's continue on trying to solve for our inequality here. We have g of x plus 2 has to be greater than or equal to 0. When we substitute g of x in here to our inequality, we're going to get negative 2x minus 8 plus 2 must be greater than or equal to 0. Or negative 2x minus 6 must be greater than or equal to 0. We can then add 6 to both sides, and then divide by negative 2. Remember that the act of dividing by negative 2 here is going to flip our inequality. We're going to get that x must be less than or equal to negative 3 in order for our composite function to be defined. In order to get the domain for our composite function, what we do is we plot the domain of g. So in our case, on the number line, I'm going to shade in everything because g is defined everywhere. And then what we need to do after this is we need to remove all of the values in the domain of g that are going to make f composed with g undefined. So anything that is greater than negative 3 is going to make our composite function undefined. So I'm going to remove all of the values that are greater than negative 3. So right now we have a diagram that represents the domain of our composite function. Our composite function must be defined on the interval negative infinity to negative 3. And I'm going to use a square bracket here because we are allowed to include the value of negative 3. Let's work through one more example here, where our function f of x is 1 over x minus 2, and our function g of x is the square root of 7 minus x. So first we're going to find the composite function. And remember, we can do this by taking the function f and substituting in the function g of x everywhere we see x. We only have one instance of x that's in the denominator down here. And making that substitution, we're going to end up with the composite function 1 over the square root of 7 minus x minus 2. And make sure that that minus 2 is outside of your square root. Next up, let's try to find the domain of our composite function. Remember that first we want to find the domain of the function g of x. In this case, g of x is not a polynomial, it's a radical function, an even radical function. So we need everything underneath our square root to be greater than or equal to 0. Subtracting 7 from both sides, you get that negative x is greater than or equal to negative 7, and we could multiply both sides by negative 1 to get that x must be less than or equal to 7. Of course, as an interval, or in interval notation, we have that x can be anywhere on the interval from negative infinity to positive 7. Next up, we want to take a look at all of the values inside the domain of g. They're going to cause us trouble when we try to do a substitution into f of x. Recall that our composite function can be thought of in the following way. F composed with g is the same thing as 1 over g of x minus 2. Now our composite function has a denominator. It's a rational function. So this function is going to be undefined if the denominator is equal to 0. So that's what we have to solve here. We're going to sub in g of x, try to solve this, and see if there are any bad values that we need to disregard in our overall domain. So let's go ahead and try to figure out where g of x minus 2 is equal to 0. Our function g of x is the square root of 7 minus x. So what we're really trying to do is solve this radical equation. We can add 2 to both sides to get that the square root of 7 minus x is equal to 2. And taking the square of both sides, we're going to get that 7 minus x is equal to 4. Next up, we could subtract 7 from both sides to get negative x is equal to negative 3. And then multiplying both sides by minus 1, we get that x is equal to 3. So just to remind you what all of this solving here is for, this is a value of x that we're not allowed to input into our function. Otherwise, f composed with g is not going to be defined. My recommendation is to try substituting the value of 3 into f composed with g and see what happens to your fraction. Like before, we're going to come down here to our number line and we're going to plot the domain of g of x by itself. The domain of g of x is all x values that are less than or equal to 7. So that plotted on our number line is going to look something like this. But we just saw that x equals to 3 is a value that we're not allowed to substitute into our composite function. So this means we have to come back to our number line and remove x equals 3 from our diagram. And that's going to leave us with the following picture. So if we want the full domain of our composite function, we're going to get the following. For this portion over here, everything before the value of 3, that's going to be the interval negative infinity to positive 3. Notice here that I'm going to use a round bracket at 3 because I don't want to include that value. This section over here between 3 and 7 is going to be the interval. We have the open bracket 3 and a closed bracket at 7 because we are allowed to include the value at 7. All right, my little epsilons, stay positive.